Hello everybody. So today I will talk about calculus. The topic today is about double integral. So now I will show you the technique. We need to wrap the function in here. About x plus y equal to b over 4. We can put about y equal to negative x plus b over 4. So we have y equal to x. That's about this one. About this one, that should be like this. The area we need to concentrate, that's about this one. According to the graph in here, we see that y, that's it on here. And x should be like this. We can find the intersection in here. That's about negative x plus b over 4 equals to x. We put negative x on the right. And we got about x equal to b over 8. And now we have the boundary for y, that is from smaller than or equal to negative x plus b over 4, and y is greater than x. About x, the boundary should be about from 0 to b over 8. And now we put everything in this boundary in here. So we have dy, that is from x to negative x plus b over 4, and this one from 0 to b over 8, and this one you got about the x. Next, we need to use about substitution. So I will put about u equal to x plus y. About y, we need to change into u minus x. So we got about du equals to dy. Because we just drew the y first, x just like the number. Now we need to change the boundary. If y equals to x, so u should be about 2x. If y equals to negative x plus b over 4, so u in this situation, you will go about b over 4. Now we need to change the new one. So x plus y we change for cosine u. Y we change for u minus s. In this situation, you got about 2s minus u. Dy we change for du. ask we change for to ask. This one we change for b over 4. Next, on numerator we can change into the new one. That should be about sine to s cosine u minus cosine to s sine u du ds. Now we can get the final answer. Cosine u divide cosine u, you got about sine 2s. Now because we have only u, so you got about u sine 2s. Cosine u, negative sine u, we can change into negative or positive, positive ln of the absolute value of cosine u, and we have cosine 2s, and we put the boundary in here. So we put b over 4 going here and here, 2s going here and here. Next, I will do about this integration and this integration. So we have 2s sine 2s ds. We use about integration by parts. We got about t equal to 2s dt. We got about 2 ds dv. We got about sine 2s. So we can find v equals to negative 1 over 2 cosine 2s. So we got the answer here. We have t multiplied with v, so we got about negative s cosine 2s, and we have the boundary from 0 to b over 8 plus, because we have negative, that's why you got the positive in here, and we got about the integral from 0 to b over 8 cosine 2s ds. So you just calculate this integration and you got the final answer. Now I will go to the second one. So we use integration by parts again. So we have t equal to ln of cosine s. So you got about dt equals to cosine 2s negative 2 sine 2s ds dv. We got about cosine 2s. If we do the integration, we got about v equal to 1 over 2 sine 2s. So we got about t multiplied with v. V minus, because we have the negative, so you change with positive. 2 1 over 2 sine 2s sine 2s. So we have about the integral from 0 to b over 8 sine 2s square over cosine 2s ds. This one, just put the number in here and you got the answer. About this one, we change into 1 minus cosine 2s square over cosine 2s So this one, we got about 1 over cosine 2s. This one, you got about negative cosine 2s. And we got the final answer. The integral of 1 over cosine 2s, you got about 1 over 2 ln of the absolute value of secant of 2s plus tan 2s. On the right, you will got about negative 1 over 2 sine 2s. And then we put the boundaries from 0 to b over 8. So I just finished through integration in here. And then this one and this one, they are symbol for you. You just do about integration of sine 2s. And this is about negative 1 over 2 b over 4 cosine 2s. And we have the boundary similar this one. And we put the boundaries in here. So I just finished about this question in here. That's it, the end. Thank you for watching.